Hey guys, Jake here coming at you with another math lesson. Today we're going to be talking about how to convert between logarithmic equations and exponential equations. Basically, logs and exponential functions are inverses of each other, which means if you have an equation like these, for example, log base 3 of 81 equals 4, or log of 1 over 1000 equals negative 3, you can convert between a logarithmic equation like these and an exponential form. So we're going to be going over how to do that. So the thing you want to keep in mind, like I said, logarithms and exponentials are inverses of each other, which basically means that if you have a given logarithmic equation like this tells you direct information about how to convert this into an exponential form. So, for example, let's say we have log base 3 of 81 equals 4. By the way, I do get a lot of people ask, or kind of misread this sort of a statement. Just to kind of emphasize that, this is how you would read this. Log base 3 of 81 equals 4. So log base something of something is basically how you would read that. And what this tells you in exponential form is that if you take 3 to the 4th power, that equals 81. So this directly tells you, just by definition of what a log is, tells you 3 to the 4th power equals 81. Okay, so that is, basically the gist of it. If you're ever trying to convert between logs and bases, essentially kind of the general form of that equation that you can use really for any of these sorts of problems is log base A of B equals C tells you that if you take whatever the base of your log is and make that the base of your exponent, so in this case we had base 3, we made it an exponent with base 3, log base A, make the base of the exponent A, and then you switch the B and the C. So you raise it to the C power, that equals B. So in this case we took the base of the log, made it the base of the exponent, and then we switched the other two components. So we took the thing that was on the other side of the equal sign and made that be the power, and then set it equal to the thing we were taking the log of. So you basically just kind of switch the place of these other two components, and that gives you your exponential equation. So let's do another example here. Let's say we have log of 1 over 1000 equals negative 3. So the thing you want to keep in mind, if they just write log and there's no base written right here, typically that implies base 10. So we want to kind of pretend like we have a base 10 right here. If they don't write the base, it's generally safe to assume that it's a base 10 log. That's kind of the default if it just says log. So when you have a log base 10, that means that we're going to apply this exact same rule. We keep the base of our log as the base of our exponent. So we're going to have 10 as the base. We're going to then switch these other two pieces. So 1 over 1000 is going to be switched to the other side of the equal sign. And the negative 3 is going to be written as our exponent. So this says 10 to the negative 3rd power equals 1 over 1000, which we know is true. Because, if you have 10 to a negative power, that converts it to be 1 over that thing. So this is the same as 1 over 10 to the 3rd power. And 10 to the 3rd power is 1000. 10 times 10 is 100. 100 times 10 is 1000. So this is equal. So the reason why this is really helpful is because if you had some sort of equation like, for example, if we had, let's say, log base 3 of x equals 4, and I know this is coming directly from this example here, but you can kind of see the use in this sort of a situation. If we have log base 3 of x equals 4, we can use this conversion to get this into a form that we can actually find x. Like if you ever have an equation that has log base something of something with x in it, like in this case it's just x. I mean, same idea would apply if we had like log base 3 of x squared plus 2 equals 4. Same exact idea. If you're ever taking log of something with the variable that you're trying to solve for, you can use this conversion to take the base of your log, make it the base of your exponent. So that'll give us 3 to the 4th power equals x squared plus 2. And then again, this gives you 81 equals x squared plus 2. And then from there, you can just, kind of algebraically continue to solve this and solve for x squared. So you could minus the 2 over, giving you 79 equals x squared, and then take the square root of both sides, giving you plus or minus square root of 79 equals x. So that's kind of the use of this sort of conversion between a logarithmic and an exponential form. But in general, you can pretty much just say that this right here is essentially the definition of it's just defined as the inverse of an exponential equation. So these kind of two things are interchangeable and will always be the case. So if you haven't already, be sure to go check out jakesmathlessons.com/precalculus-study-guide or scan this QR code in the upper right-hand corner of your screen here. It's a great resource. It's going to save you a ton of time and frustration as you study and do homework and stuff. And if you do want to keep this brain train rolling, just go click on that video right over there that I made recently, and we can keep going on some of this stuff. Thanks, and see you next time.